Most people imagine a ship propeller is just a giant metal fan bolted onto the back of a boat. But the factory reality is not in the way you imagine. This single 50-ton bronze beast can drive a 200,000-ton container ship across the Pacific at 25 knots, or shake the entire vessel to pieces if one blade is off by the width of a human hair. And almost nobody has ever seen how it's actually forged inside a modern shipyard. How massive ship propellers are forged, not in the way you imagine. Every single day, thousands of these monsters leave factories in South Korea, China, and Germany and head straight to ports of Los Angeles, Southampton, and Melbourne. They are the beating heart of global trade in 2026. Without them, your Amazon package, your morning coffee, and the next cruise ship you step on simply don't move. But here's the part that still shocks even seasoned marine engineers. The real magic doesn't happen at sea, it happens at a foundry, so hot it feels like standing inside a volcano. And one tiny mistake in this process can cost a shipping company $8 million in a single voyage. Ready to step inside? But before a single drop of metal is poured, the factory makes a decision that will decide if this propeller survives 25 years at sea or fails in year 3. Giant furnaces roar like dragons. Workers in heat-resistant suits feed in precise mixes of copper, tin, and nickel. This isn't ordinary bronze. It's a secret marine alloy that can resist saltwater corrosion better than titanium, yet still flex just enough to absorb the insane forces of the ocean. Think that's impressive? Wait until you see what happens when they pour it. The mold. Now comes the part almost no one outside these walls has ever witnessed. A sand mold the size of a small house is painstakingly built around a full-scale wooden pattern. Every curve, every blade angle, is measured to tolerances thinner than a credit card. One wrong millimeter here, and the finished propeller will create deadly cavitation bubbles that eat metal like acid. But the real danger is still coming. The pour, the moment of truth. 60 tons of glowing orange liquid metal cascades into mold like a river of fire. The heat is so intense the air itself shimmers. Sparks fly. The ground vibrates. The single pour takes 18 hours to cool, and if it cools too fast or too slow, microscopic cracks form that will never be seen until the propeller is already spinning at full speed in the middle of the ocean. Most people would stop here and call it finished. The factory is just getting started. Rough machining. Now the real engineering begins. Massive CNC machines taller than 2-story buildings chew away excess metal with diamond-tipped tools spinning at 10,000 revolutions per minute. The sound is deafening. Blue coolant sprays everywhere like a mechanical storm. They're carving the perfect hydrodynamic shape that will slice through water with almost zero resistance, something no human I could design without supercomputers. Pattern interrupt. But here's where things get dangerous. But building the propeller is only half the story. The real test happens when this 50-ton giant meets the ocean, and one invisible flaw can create vibrations strong enough to crack the ship's hull. What they do next inside this factory is the difference between a safe voyage and a multi-million-dollar disaster. Precision balancing. Time for the most delicate operation in the entire process. The propeller is mounted on the world's largest balancing machine. Laser sensors scan every millimeter while it spins faster and faster. Sol plus a prize. They remove metal so precisely that the final balance is accurate to 0.01 millimeters. That's thinner than a strand of hair. 1 gram off on a 50-ton blade, and the entire ship will shake itself apart at cruising speed. Still not finished. Cavitation testing. Now comes the moment that separates a great propeller from a floating disaster. In a special pressure tank filled with water, they fire up the propeller at full power while high-speed cameras record every bubble. Those bubbles, they collapse with the force of a tiny explosion, creating shock waves that can pit steel like machine gun fire. The factory engineers tweak the blade shape until cavitation is almost eliminated. This is why your next cargo ship or cruise liner feels so smooth, even in heavy seas. After weeks of heat, pressure, lasers, and testing, here it is, a 50-ton masterpiece of engineering, ready to be shipped to ports in Los Angeles, London, or Sydney. One single propeller that will push billions of dollars of goods across the planet for the next quarter century. This is a hidden factory reality behind every modern ship you see on the horizon. Not magic, not guesswork, just raw, precise, jaw-dropping engineering. Done exactly not in the way you imagine. If you want to see how ship rudders, anchor chains, or stabilizer fins are built next, hit that subscribe button and turn on notifications. Drop a comment right now. Which ship part should we reveal in the next video? And if you're new here, check out our anchor video in the Ship Secrets playlist. It's the perfect starting point. I'll see you in the next factory. Until then, keep questioning what you think you know.